Welcome back to Algebra 1. We're still in radicals. We are on page 291, talking about simplifying radicals, especially that are fractions. Rationalizing the denominator means that you cannot have a fraction, the bottom cannot be under a radical. When you have a whole radical like this that's over both of them, that means this is in a radical and that's in a radical. It also can be written like this. Both of those are the exact same thing, okay? And when you rationalize a denominator, it means there cannot be a radical on the bottom of that fraction, just like there cannot be a fraction on the bottom of a fraction. So these are simplifying steps, and all of these are going to be fractions. So we're going to start with number 1, and number 1's a fairly simple one. It may look scary, but it's not too bad. This is a square root because we don't have a sign out here, so it means square root, and both of these are perfect squares. So all we need to do is take the square roots. The square root of 9 is 3, and the square root of 64 is 8, and that one's done. We didn't really have to do anything. That is just normal radical simplification, but they're not all that easy, of course. So let's look at number 6. It is a cube root. You must pay attention to the root. That pretty much means everything here. When you're trying to pull out, in order to rationalize this, you need to make this a perfect cube, because this is a cube root, in order to pull it out of the radical. So you got to ask yourself, what can I multiply by 3 by to get a perfect cube? Well, if you write down some of the cubes, 2 cubed is 8, 3 cubed is 27, and 4 cubed is 64. The smallest one, because I'm not going to multiply anything by 3 to get 8, so I need to make 27. What do I multiply 3 by to get 27? Well, the answer to that would be 9, right? 9 times 3 is 27. Whatever I multiply the bottom by, I have to multiply the top by it as well. So when I rewrite this, 4 times 9 is 36, and 3 times 9 is 27. Okay, now on the bottom there's a cube root of 27. That was the whole point of this, which is 3. I pull that out to the outside. Okay, if there's not a number out here, there's a 1 out there, and then I have radical 36, the cube root of that. Is there anything that I can pull out of that? Well, what I need to look for is 8 going to go in there evenly? No. Is 27 going in there evenly? No, and 64 is bigger than that. So this is simplified, and that is your answer. It's okay to have a radical in the top. It is not okay to have a radical in the bottom. Okay, so pay attention to the index, because that's what's going to help you figure out what to multiply that by. So switching gears, we're going to go up here to number 12. Number 12, there's not a radical in the top. There is a radical in the bottom. 68, it's a square root. That's not a perfect square. And can we simplify that any further, which means can we break that down into a smaller radical to figure it out? So we got to ask ourselves, on our perfect squares, what can I get to make 68? So I can say 68 divided by 2 is 34. Neither one of those are perfect squares. (68) divided by 4 is 17, is times 17. So if I multiply this and do 4 times 17, I can go ahead and pull out my 2. Square root of 4 is 2. It comes to the outside, and now I have this. 17 is prime, so I know there's nothing I can multiply to get that out. So now I have to make this a perfect square. Well, if I list some of my perfect squares, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. Okay, we're going to see if 17 goes into any of those evenly. If not, if we get that far and we don't find it, we'll just multiply it by itself, which will make it a square. But if we can find something smaller, we will. So I will start with 49 and divide by 17. Nope. We know it's not, well, 64 divided by 17. Nope. 81 divided by 17. Nope. And I know 100 doesn't go in there. So we're just going to go ahead and multiply by radical 17 on both. Okay? So at the top, 10 times radical 17 will be 10 radical 17. On the bottom, 17 times 17 is radical 289. And we have a 2 on the outside. But this has a perfect square root. Okay? It's 17 because we just multiplied 17 by 17. So if I do that, 17 comes out and gets multiplied here. So I would actually have 10 over 34 and a radical 17 right there. I still have to reduce this fraction. They're both even numbers. So 2 goes into 10 5 times. It goes into 34 17 times. So your answer for this problem is 5 radical 17 over 17. Okay? So see, you can see that it gets a little bit more complicated as it goes on. Alright, everybody got that? I need to clear that out of my way for the next one. Alright, number 19 I picked because it's a fifth root. We don't really work with those a whole lot. So it's going to take a little bit of extra work. Not too much because that's a 2. So that's not a big deal. We just need to figure out what a fifth root is. Let me let that dry. Grab a paper towel, and I know this sounds horrible on the video. I don't like it. I sound like one of those things on those ASMR videos. Alright, so on this problem, okay, if I rewrite it to look like this, I need that radical 2 out of there. Well, guess what? 2 times 2 is 4. That's not a fifth root. I need to find some fifth roots. So I will write some. I don't need to go far, and I'll show you why in a minute. 2 to the fifth root is saying 2 times 2 times 2 times 2 times 2. Okay, I think I want to say it's 32 or 64, but it's 32. Okay, 32 is an even number, therefore I can multiply by something to get 32. So what do you multiply 2 by to get 32? 16. So I got radical 16 and radical 16. Alright, because this is going to make this a fifth root. When I look at my top, 3 times 16 is 48x. And 2 times 16 would be 32. Okay, there is a fifth root of 32. It is 2. So that comes out. Alright, so now I got a 2 down there. And I have a 48x on the top. Alright, can that be simplified further? I don't think so. All I need to do, 32 is not going in there evenly. I just need to make sure this one is over 48. If so, we can't get a fifth root out. So 3 to the fifth power is 243. So absolutely not. That's not going to go into 48. So this is simplified. The button that you can use on your scientific calculator, and they do not have to be very expensive. I never pay over $10 for mine. I have several of them. You can have a button that maybe looks like this. If you have it, and it could say X to the Y or Y to the X, either one, you press your number, then you hit shift or second, or no, don't hit that, that's for the back function. That's for the one that looks like this if you're doing a root. But if you hit 2, hit this button, and then hit 5, that'll be 2 to the 5th power, and it will work it out for you, okay? So use that. If not, go 2 times 2 times 2 times 2 times 2. Either way. All right, so I think we are on 28 now, so let me clear this off a little bit. Remember, you just want to pay attention to that root. That root is going to be the knowledge that you need to figure out what kind of root you're getting. So this is a 4th root. I picked this one because we haven't dealt with a 4th root yet. Alright, still filming. I need to cut my face out when I'm looking at that. It's blinking at me for some reason, and I'm not sure why. I need to list some of the 4th roots so that I know what I need to multiply 25 by to get a 4th root. So 2 to the 4th, 3 to the 4th, 4 to the 4th, and 5 to the 4th. And 2 to the 4th is probably 16. Yeah. 3 to the 4th is 81. 4 to the 4th is 256. 5 to the 4th, 625. And I shouldn't have to go any higher than that. Which one of these numbers will 25 go into evenly? Well, it's not going to be 16. This is a 5, so it can only go into things that end in 5 or 0. It's not going to be any of these. It's going to be this one. Okay? So what do I have to multiply 25 by to get 625? So I'll do 625 divided by 25. And that's going to be 25. Alright. Move that out of my way. 25 there. I'm going to have to multiply by 25 up here. But this one has x's and y's in them. And the thing that you need to know here is that exponent needs to be divisible by this. So if this is x to the 1st power, I need this to be x3 because we add exponents when we multiply. So 1 plus 3 will make the 4 that I need. On y2, this is going to be a y2 because 2 plus 2 makes 4. Okay? Whatever I do by the bottom, I have to do at the top. Alright? So at the top now, in radical, I will have 25x3y2. That's okay. Nothing's going to happen. I can't break that down. I'm going to leave it alone. And then on the bottom, I'm going to have radical 625, because 25 times 25 is 625, x to the 4th, y to the 4th. All of those are 4th roots. So 4th root of that is 25. The 4th root of this would be 4 divided by 4, which is 1, so x to the 1st. And for y, y to the 4th divided by 4 is y. Okay, that's outside. Got to put a 1 over it because it's on the bottom. And then my stuff up here stays 25x3y squared. Okay, so that's my answer simplified. I cannot do anything with this out of the radical and this in the radical. You can't simplify that, okay? If there was a number up here, like a 5, yes, you could simplify, or an x or something, you could cross them out. But there's not one. All right, the last one we're going to do is problem 32. And I'm going to come over here and work on this side. And 32 just has a little bit more letters in it, so I want it to go ahead and work that. This is the problem, 32. And this is a cube root, okay, which is good. Cube roots should be coming a little bit familiar to you. And there's the first 3 perfect cubes. So again, this is a 3. The first one it's going to go into is 27. So what do you multiply 3 by to get 27? That's got to be a 9. So that's one thing. And you can use a dot or you can use parentheses. Both of them mean multiplication, so it's fine either way. And they should, I didn't write that one under the radical, but you are multiplying them under a radical. What is going to make this y a 3 so that you can divide that out? Well, that's a 1 there. We don't write it, but it's there. So this has to be y2 because 2 plus 1 makes 3. And when we multiply radical, or when we multiply in algebra, we add the exponents. All right, so now when I multiply that across on the top, I'm going to get 9xy squared. These should go alphabetically, so x should come before y. If you write it the other way, it's okay. It's not really wrong. It's just not preferable. And I can't do anything with that because there's no cube root. I don't know why my index is so big. It needs to be smaller. But you can't do anything with that. Leave it alone. On the bottom now, I will have 3 times 9, which would be 27. And then I will have y3. Well, the cube root of 27 is 3, so that comes out. And the cube root of y3, 3 goes into 3 one time, so there's 1y out here. Okay, this is on the top. Wow. And that's your answer. Again, you can't simplify 1 and 3, but if there was something out there that you could, if this was a 9 or if it had a y out there, you could cancel some stuff on the outside out. Otherwise, this is how it stays. All right? All right, do your best. Thanks for watching. Have a good day.